All right, we're going to take a quick look here at factoring special products. So these were the special products that when you were multiplying different binomials in the past ended up with. And that was, hey, if I had a plus b times a minus b, I get a squared minus b squared, a difference of squares. Or if you had a binomial squared, it came out to a squared plus 2ab minus b squared. Or if I didn't put the subtraction one up here, if I put the subtraction one, the a squared minus 2ab plus b squared. Those were those special products that you had in the past. And here's the bottom line. They're not special. There's nothing special about them. It's the same distributive property you do for everything else. So for example, this guy right here, a minus b squared is really a minus b times a minus b. That's going to give me a squared minus ab minus ab plus b squared, which would be a squared minus the 2ab plus the b squared. Nothing special about the products, really. I mean, they say they're special because they end up a certain way, but it's still the same old multiplying. So what we want to remember is, hey, if I'm going to be factoring special products, they're not special. There's nothing special about the factoring. I'm going to follow the same process. So my process was, hey, my sign pattern, if that last term's negative, one of each. If that last term's positive, they're like. Okay? I'm going to split that front, split the back, check and correct. So let's look at something like this. Right? Let's look at that difference of squares. If I had x squared minus 64, right, and I want to factor this, hey, my last term's negative. Since my last term's negative, I've got one of each. So I'm going to have a plus and a minus. I split the front, x squared, x, 64, 8, 8. I check. Negative 8, positive 8. Hey, that gives me 0. Well, that's what I wanted because there is no middle term. I didn't do anything special in the factoring aspect. I followed the same thing I did when I was factoring trinomials. Same steps. Sign pattern. Let's get that first term factored, get the last term factored, check and correct. Let's say we had a 4x squared minus 25. Right? So again, that is a difference of squares, but I'm not thinking of it as a special case. I'm just factoring. Last term's negative. Plus, minus. Factor the front, I got a 2x, x, back, 5, 5. There's no middle, so I'm trying to get a 0. So let's see, negative 10, positive 10. That's 0, that's what I wanted. I've got that factored, following my same methods of factoring before. Now, hey, well, what if the last term's positive? Well, if the last term's positive, I'm supposed to look at the middle term. I know they're like. So if the last term's positive, either have two positives or two negatives. Right? So in order for me to try to factor this thing, I know they're the same. I'm supposed to look at the middle term. There is no middle term. That means I cannot set up the sign pattern. If I can't set the sign pattern up, I can't factor it. I can't set it up. Again, I know they're supposed to be the same. The middle term is going to tell me. Let me give you an old example from previous factoring. Let's say we had x squared plus 5x plus 6. Hey, I know that's plus and plus because of that middle term. But yet if this was a minus, now I know it's minus minus. If there is no middle term, I can't determine the sign pattern. That's why a sum of squares doesn't factor. So this is not factorable because I can't even do the sign pattern. These were factorable, sign patterns plus minus plus minus. Okay. Now, let's say that I mess up and I go, all right, well, what if it's positive? Both positive. All right. Outside terms 2x, inside 2. That's 4x, but I don't have a 4x. Well, that means they must be negatives. Negative 2x, that's negative 4x. I don't have a negative 4x. Well, they must be opposite then, because that would give me a 0. But that would also give me a negative 4 on the end, not a positive 4. So this is not factorable. I'm trusting my sign pattern like I have before. The other type. It's something like this. Let's go x squared plus 6x plus 9. I'm looking to factor this. This is going to represent that was the square one that we saw earlier. But let's take a look at it. I'm going to factor like normal. Normal, what I would normally think if I want to do. Okay. So first, our sign pattern first. Plus, plus. X, X. There's my front. The back. 3, 3. I check. That's a positive 3 and a positive 3. Well, a positive 3 and a positive 3 is definitely a 6. That's what I wanted. That's correctly factored. The same thing repeats. If I see the same thing repeat, I can write it together like that, x plus 3 squared. One extra step because the same thing repeated. Hey, same thing didn't repeat here. So they're staying separate. Here, same thing repeated. I can write it together. But still, nothing special about how I went through my factoring process. Let's look at another one here. Let's go x squared minus 12x plus 36. Nothing in common. Go right to my sign pattern. Minus, minus. Split the x, x, x. 36, 6, 6. I'm trying to get a negative 12 in the middle. Negative 6 and negative 6. Hey, that's negative 12. I'm good there. It's factored. However, same thing repeated. That means I could actually write it together. Again, I'm working my same factoring process that I have done in the past.